Hi guys, this is part 2 of instructional video 9.3 on predicting products of chemical reactions. So now we're going to look at the two replacement reactions, so single replacement, double replacement, and combustion reactions. So just a reminder, in order to do this, you have to remember your diatomics, which is your Brinkelhoffs. When they are alone, these guys have to have a subscript of 2, only when they are alone. And then we're going to use the crisscross reduce method using the charges. And I reviewed this back in the part 1 video. All right, so first, what we're going to need is this thing called the activity series. And I have posted a page on that on modules. It's called activity series. And it's just a picture of this here. Now, here's how you use this. Anything higher up here is most reactive, and then as you move lower, it gets less reactive. So lithium is the most reactive metal, and gold is the least reactive metal. And then that makes sense, because I told you anything group 1 and group 2, especially group 1, when you put them in water, they explode in water. They're very highly reactive. And then all these, you'll recognize silver, platinum, gold. These are all the jewelry metals. These are the ones that we like to use because they aren't very reactive, because you don't want anything that's going to explode when it comes in contact with your skin, right? Okay, so anything group 1, group 2 is going to be highest up, and then anything transition metals are going to be lower down. All right, so let's first talk about single replacement. So here's rule number 1. Using the activity series, a more active metal will replace a less active metal. So all you need to know is which one is higher up. The higher metals will actually be in the compounds. So most reactive versus least reactive, whichever is higher up, is going to be in the compound. So let me show you what that means. So here we have Mg plus AgCl. So we're comparing the activity series using these two metals. So we have Mg and Ag. Well, Ag is down here. It's very low on the activity series. And Mg is all the way up here. So Mg is higher up, Mg is our winner, and it gets to be in the compound. So Mg is going to bump out silver here because it's more reactive. So what we're going to get here is Ag is going to be alone, and then we're going to have Mg with Cl. So first we have to check Brinkelhoff for Ag. Ag is not a Brinkelhoff, so it does not need a subscript. And then we need to do crisscross and reduce with Mg and Cl. Mg has a 2 charge, Cl has a 1 charge, so we're going to get Mg, Cl2, and then plus Ag with no subscript, and then you would go back and balance it, and you would get this. Let's try another one. Here we have lead alone, and we have zinc with chlorine. So we're going to compare lead and zinc. So let's see. Lead is here, and zinc is up here. So zinc is higher up, zinc is the winner, and zinc gets to be in the compound. And I notice that zinc already is in the compound. So a less reactive metal cannot replace the more reactive metal. So for this, you would say NR, or no reaction, because you can't switch out a less reactive with a more reactive. So no reaction would take place here. All right, rule number 2 says halogens, and halogens are group 17. Halogens will replace other halogens based on where they are on the periodic table, higher up. So anything higher up then is going to replace anything that's lower down. So if you look at your periodic table, and I'm going to pull mine up, okay, it goes FClBri. Okay, so F is going to be most reactive, and then we're going to go further down, it will be less reactive. So let's look at this example. This is the halogen we're looking at, and this is the halogen we're looking at, not aluminum in this case. Okay, so bromine and chlorine, who is higher up? Chlorine is higher up, so chlorine wins. He's going to bump out bromine. We have to remember Brinkelhoff, and we have to remember crisscross and reduce. So in this case, bromine's going to be alone. Bromine is a Brinkelhoff, so he's going to need a subscript of 2, and then the crisscross and reduce. So aluminum has a 3 charge, chlorine has a 1 charge. If you crisscross and reduce that, we're going to get Al, Cl3, and Br2 because of Brinkelhoff, and then you would go back and balance this equation, which you already know how to do. That's so the third rule, okay, is group 1 and group 2 metals. So lithium, sodium, potassium, that's group 1, and then beryllium, magnesium, calcium, that's group 2. Anybody in those groups, okay? When they are added to water, so plus H2O, they will produce a metal hydroxide, okay? So the metal they gave you plus OH, and hydrogen gas. Now, hydrogen gas is a Brinkelhoff, so that's H2. So here's our first example. Na, which is a group 1 metal, plus water, so we're looking at this rule here, is going to produce hydrogen gas, so H2, and a metal hydroxide, Na and OH. Again, crisscross and reduce. You guys know that OH, which is hydroxide, has a 1 charge, -1, and sodium has a 1 charge, so you're just going to get NaOH plus H2, and then you would go back and balance that. Very simple. All right, now let's look at double replacement reactions. Okay, so here's the rule. The anions will switch places. So remember that picture where everybody traded partners? That's essentially what we're doing, or we're going to trade the last name. So let's look at this. So let me pull up my pen here. See if I can do this. Now, you want to be careful and not totally rip apart everything, okay? These are considered the last names, okay? So sometimes it's connected to a polyatomic and sometimes it's just connected to an element, okay? You're going to take these guys and switch them, all right? And then crisscross and reduce based on charges. That's it. So Na is now going to be with Cl, and Ca, calcium, is now going to be with CO3, okay? So Na has a 1 charge, and Cl is a 1 charge. And then calcium has a 2 charge, and so does CO3. Okay, and then you would go back and balance that. Okay. Now, same thing here. We're going to split these guys apart, and we're going to keep this guy whole, and we're going to keep this guy whole, and we're just going to switch out the H and the K. All right, so H is now going to be with OH, and K is now going to be with NO3. Okay, so I know, looking at the periodic table, that potassium has a 1 charge, and so does NO3. So we're going to get K, NO3, and HOH. Now that's not a thing, guys. How do we actually represent that? We represent that as H2O, water. Okay, and then you go back and balance that like that. Okay. So here are some examples. Please try these. I have the answers at the end of this slideshow. So pause the video, go back and try to answer these, and I'll give you the answers at the end. All right, last but not least is combustion, and it is the easiest one because it's the same thing all the time. So combustion reactions always produced CO2 and water, H2O, okay? So first, you have to identify that this is not a single replacement or a synthesis. This is a combustion reaction, okay? It's very easy to get confused. This is a combustion reaction. It's going to produce CO2 and H2O. And if you had to, you would go back and balance that, okay? All the time. That's it, the end. You don't have to do anything else besides balance if necessary. All right, now here are the answers to the previous examples. So hopefully you guys had a chance to try them. And here they are. Let me know if you guys have any more questions, and good luck.